So we're going to be using the same steps again to solve these next couple inequalities. So on number 2, we have to get 0 on one side to begin. So we minus the 18 on both sides. And now we have 0 on one side. And so now we treat this like an equation instead. So we pretend like there's an equal sign there. We see if we can solve it by factoring. So factoring, we look for what times what gives me negative 18 and adds together to be negative 3. So we have 1 and 18, 2 and 9, 3 and 6. Looks like 3 and 6. And if I make the 6 negative, that makes it work for the top and the bottom. So that will help us factor. But remember, we have to set each of these individually equal to 0. So that means we're going to get x equals negative 3 and positive 6. So remember, for the inequalities, though, we're not looking for where it's equal. We want to know where it's like less. In this case, that's less than or equal to. And so we set up a number line with those two numbers we just found. Negative 3 is lower, 6 is higher. And we pick some test values in between. So I'm going to pick a 0. 0 is always easier for me, at least, to plug in. And then we'll pick, I'll just do a 7 since that's a little bit bigger, and a negative 4 since that's a little smaller. So you can plug it into either this one or this one. It doesn't matter. Doesn't matter which one. So let's do negative 4, and I'm going to do the factored version. So negative 4 plus 3. That's just easier for me to see whether it's positive, going to be positive or negative. Negative 4 and minus 6. That's going to be a negative number. This is going to be a negative number. So this is going to be a positive section. So all the numbers there are going to have positive answers. So the next section, we plug in a 0 into that same equation. So 0 plus 3, 0 minus 6. So that's going to be a positive. That one's going to be negative. So that's going to be a section of negative numbers. Let's plug in a 7. So we have 7 plus 3, 7 minus 6. Those are both going to be positive. So we have a positive and a positive. So that's going to be positive answers in that section. So now we just have to figure out, write our answers. We're looking for where it is less than or equal to 0. So that time, this time we're looking for all the negative numbers. Those are less than or equal to 0. So since we have an equal to part, our answers are always also going to have equal to. So for our inequality, we have this section. It's only the one section. So we need one section. It's going to be the equal to. It's going to include equal to on both sides. And make sure they're both going the same direction. So you start with your lowest number, which is negative 3, and that's less than or equal to x, which is less than or equal to 6. So that would be our inequality. And then we're looking for our interval form as well. So it's only one section, so we'll have one interval. It has the equal to, so we're going to be using the brackets on both sides. So from negative 3 all the way up to positive 6, including both sides. So there's our solution. So let's try this one. Go ahead and pause and try this one. And then we'll go through it. So you want it equal to 0, so you add 40 to both sides. At the same time, I'm also going to minus 13x from both sides. So that goes to 0, that goes to 0. And remember, you can only combine like terms here. So negative 13x just becomes our second, in standard form, our second term, plus 42 greater than 0. So now we're on to factoring, solving this by factoring. So what times what gives me 42, and it needs to add together to be negative 13. So 42, we have lots of options, 1 and 42, 2 and 21, 3 and 14, but I think 6 times 7 is going to be our magic numbers, and they add together to be negative 13. That's why I had to make them both negative. So we factor using those two magic numbers. And so this time, our solutions are going to be 6 and 7 when we solve those. So let's make our number line over here, looking for our intervals now. We're looking at 6 and 7. So this time when I'm picking my test numbers, I'm going to have to use a decimal because I have to get a number between 6 and 7. So 6.5. I'm going to plug in a 0 as well, and then we'll do 8 on this side. So I'm going to plug it into this part right here. 0 minus 6, 0 minus 7. So I'm going to get a negative number here, negative number here. So that will end up being positive. Plug in the 6.5, so 6.5 minus 6, 6.5 minus 7. So this will be a positive, this will be a negative, so that will end up being a negative in the middle. And just so you know, they don't always end up this way, so with positives on the outside, but let's check just to be sure. So 8 minus 6, 8 minus 7, so that'll be positive, that's a positive, so this will be positive. Okay, this time we're looking for where it is greater, so we're looking on the outside, ready to write our answers down. This time there's no equal to, so for our inequality, we have to write the two separate inequalities. So we have all x values that are less than 6, or x values that are greater than 7. And then interval notation, we have to write them separately as well, but it looks a little bit differently from negative infinity. So remember, we have to do this whole section right here. So that section all the way up to here. So negative infinity all the way up to 6, not including 6, so that gets a parenthesis. And then we have this section over here, not including the 7. So we do our union, and then 7 to positive infinity. And there's our solution there. On the next one, I'm going to show you a little bit of a different method to find your intervals that are going to work for you. So let's try this out. We start the same way. We want this equal to 0, or we want 0 on one side. It's not equal because it's not an equation, but minus 4, since we don't have any like terms. Okay, and now we're ready to factor. So again, we have a 2 up here. So we have to take the 2 times negative 4 for our top number, negative 8. Has to multiply to be negative 8 and add together to be positive 7. So that's going to be 1 times 8 with a negative over there. But remember, this one's a little bit harder. You have some extra steps when a does not equal 1. We use our magic numbers to split the middle term. The first term and the last term stay the same, but we split the middle term using those two numbers. So we have minus 1x. Since that has an x, these both get an x, plus 8x. That's where our magic numbers go right here. And now we factor by grouping. So we split this in half. The GCF over here is x. The GCF over here is 2. Oh, sorry, it's 4. It's a common factor, but not the greatest common factor. 2x minus 1. One more step with factoring. So our greatest common factor now is 2x minus 1 on both sides. And we're left with x plus 4. Okay, so we have to continue to solve this though. So either 2x minus 1 equals 0. We're pretending like we have an equation here for a second. Or x plus 4 equals 0. So on this one, we get a negative 4. On this one, though, we have an extra step. So we have to add 1 to both sides, but then we have to divide by 2. So we have negative 4 and 1/2. Those are going to be our two x values, so that when we set up our number line, negative 4 is our lower, 1/2 is our upper. Okay, now in this case, though, I want you to think about what the graph of this looks like. So looking back at, let's go back to this point right here. Once we have 0 on one side. So that graph right there, remember this is a quadratic, so it's going to be a parabola, either this way or this way. And in this case, do you remember how to tell which way it goes? It's all according to your A up here. If it's positive, it goes this way. If it's negative, it goes this way. So for us, this is positive. So if I did graph this, it would go this way. And what we just solved for are actually our x-intercepts. So the question now is, where is this greater than or equal to 0? So can you tell from the graph where it's greater than or equal to 0? So we know it's equal to on these ones. We know we're going to include that because of the equal to part. But this middle section is below the x-axis, so that's our negative. The outside sections are above the x-axis, so those are going to be positive. So where is it greater than or equal to 0? On the outside. So you don't, in this case strategy, you don't have to plug in numbers, figure it out from there. So if you know the shape of the graph, you can figure out where it is, where your solutions are going to be. So interval notation, here we go. We have two different pieces. So we have x is less than or equal to -4 on the left, or, and you do have to use that or, x is greater than or equal to 1/2 on the right. And then in interval notation, we have parenthesis, -infinity all the way up to -4, including -4, with a union starting at 1/2 all the way up to positive infinity. So those are your two resources, or two solutions. Okay, on this one, same idea, but it's ready for us to factor. We already have 0 on one side, so we multiply those two together, and we're looking for what times what gives me 8, adds together to be -9. So these are going to be my magic numbers this time. But again, we're not ready to factor yet. We're just setting it up to factor since I have a 4 up here. So the 4x squared and the 2, the plus 2 stay the same. This middle term, though, gets split up with my two magic numbers, -1x, -8x. And now I'm ready to factor by grouping. So GCF over here is x. GCF over here is -2. And I'm doing a negative because this is negative. And I want to end up with a positive 4x, so it'll be the same as the other side. And now my GCF of the whole thing is 4x minus 1, and I'm left with x minus 2. So when I solve these, this one gets me an x equals 2. This one I do plus 1 divided by 4, so we're going to get positive 1/4 on this one. Those are my two numbers for my number line. So 1/4 is lower, 2 is higher. And looking at the shape of the graph, this over here has a positive, so it's going to go this way again. So this is a positive, this is negative because it's below, and this side is above the x-axis. So let's see what we're looking for here. So we're looking for where this is greater than or equal to 0. So again, it's going to be these outside pieces. So we want the numbers where x is less than or equal to, since we have it equal to, 1/4, or where x is greater than or equal to 2. And then in interval, we have -infinity to 1/4, including 1/4, or with a union from 2 to positive infinity. There we go. This one, I do want you to think about this graphically. If we add 25 to both sides, we want to know where that's less than 0. Looking at the graph, and you think about x squared plus 25, x squared looks like this. Oops, but it goes through the origin. More like this. But plus 25 means it moves up 25, so it goes up to 25 right here. So if the question is, where is this less than 0? Basically, I'm looking for where is this below the x-axis? And the answer is never. This would be a no solution situation. But what if I did that same thing, but I just changed the symbol? So I want to know, where is this greater than or equal to 0? So once you get that switched, plus 25, where is that greater than or equal to 0? And that would be all real numbers. It's always greater than or equal to 0. So in that case, we could say all real numbers are our solution. And we can also write in interval notation from -infinity all the way to positive infinity. So that would be it.